Hello and welcome to this Dr. Frost video on dividing algebraic fractions requiring prior factorisation, excluding non-monic quadratics. Now we just want to express this division of two algebraic fractions as a single fraction in its simplest form. Now let's remind ourselves how we divide normal fractions. If, for example, we had 3 divided by 5 divided by 9 over 10, what do? Well, you might remember keep, change, flip. So you keep the 3/5 as it is, you change the divide into a times, and you flip, or the mathematical term is reciprocate this second fraction here, so that becomes 10 over 9. And then remember, to multiply two fractions, you just multiply the numerators. You could do 3 times 10 is 30, and 5 times 9 is 45. You multiply the denominators as well. But do you remember that you can actually cross-cancel? So we know when we simplify a fraction, for example, 3 over 6, we could divide top and bottom by 3, and that gives you 1 over 2. So we can divide top and bottom of within that one fraction, but we can also divide top and bottom across fractions. So if we've got something in the numerator here, something in the denominator here, they're not in the same fraction, but that's okay. You could divide both of those by 3. So the 3 becomes 1, the 9 becomes 3. And similarly here, the 10 and the 5. The 10 you could divide by 5 to become 2. You could divide the 5 by 5 to become 1. Then 1 times 2 is 2. 1 times 3 is 3, and then that becomes a lot easier. You don't have to simplify the fraction after you've multiplied these together. Now we're going to do the same thing here. So if I just copy out the question, but in order to have things to divide by, just like we had things to divide by here, we need to factorise everything we can first. Now actually the first thing I do is to turn this into a multiplication. So we're going to do keep, we keep this as it is. We change the divide into a times, and we flip, we reciprocate that second fraction. And now we're just going to factorise everything that we can so that we have stuff to divide by. So how do we factorise this quadratic? Remember, we find two numbers that add to give the number in front of the x and times to give the constant term at the end. If that's not familiar to you, please look at my video about how we factorise quadratics first. And what are those two numbers? Well, 5 and 1 add to give 6, they times to give 5. So the way we do it is two brackets. We have x at the start of each, because this is a quadratic in terms of x. And then the 5 and 1, either way round, we put in those two brackets. So that is the factorisation of that. 8, we'll just keep as 8. And then we've got 2 over. Now, how does this factorise? Well, this is known as the difference of two squares, and we explore that in another video, and that's because it's a difference, a subtraction, of two squared things. X squared is a squared thing, it's x squared, and 25 is a square thing, it's a square number, isn't it? It's 5 squared. So the way we factorise it, two brackets, one with plus in the middle, one with minus, and we do the square root of the first thing. The square root of x squared is just x, and we do the square root of the 25, the second thing. The square root of 25 is 5, so we put the 5 as the second thing in each. Now we can do what we did up here and either cross cancel or just cancel. Well, there's nothing to cancel top and bottom here, there's nothing common to the top and bottom divide by, the same here, but we can cross cancel. So if we look at the 2 and the 8, they're both divisible by 2, so the 8 becomes 4 if we divide it by 2, and the 2 when you divide it by 2 becomes 1. Now what about this direction? Well, we can see there's an x plus 5 and an x plus 5 here, so let's cross those out. We divide by the x plus 5s to get rid of them. And then there's nothing else I can see that's common here and here. So what have we got left? We've got x plus 1 times 1, which is just x plus 1. And then we got 4 times x minus 5. You could just write 4 brackets x minus 5. That means 4 times x minus 5. Now you could expand that if you want, but in factorised form it's just as simple as expanded form. So there's no reason to expand that out, and that is the final answer.